Today we'll be discussing more about microservices. So last time we covered the fundamentals of microservices. We will build upon further from that session. So yes. Okay, let me first list down the number of microservices pattern. We covered few patterns last time, and we'll be covering more patterns with examples from e-commerce application, right? So any questions from the previous sessions?
No, sir.
Okay, great. Okay, so yeah, we saw that we built up a microservice last time. We built up an e-commerce application. So we created an e-commerce application with various microservices. We first built it up with the monolith approach. Then there were some problems, concerns. We discussed the differences. And then we built up a microservice. And now let me share again the high-level architecture. So we had a mobile application, right? So what we were doing was, assume we had some mobile application, and this is your client. Any application will have a client, right? And now with client, right? So client will communicate to various services. So we have here in our e-commerce app, right? See, this is the internet. Okay, let me divide it with dotted round line. We have various microservices. Say we have product catalog, right? This is a microservice. Then we have probably another service which is called order processing. Let's call this order processing. Okay. Let's have another service, which is, let's say, the shopping cart service, right? So you have a shopping cart. Right, and then you have a payment processing service. Right, maybe it talks to some external services as well. So yeah, payment processor service talks to payment gateway. We already discussed the design of payment gateway in a separate session, right? And there may be many more services. So clients will be connecting to these microservices. So when they have to make a call and search for the products, maybe they will be calling product catalog service. When they have to call with, when they add items to product catalog, basically to shopping cart, when they choose a product to purchase, then they may be adding it in the shopping cart. And from the shopping cart, they may have a order button. So you may have order processing. Order processing may also be connecting to product catalog to verify the product, maybe there is another services, which is inventory management, right? So this service may provide details about whether the item is in the stock, right? You may get the product price from the product catalog service. And then probably once the order is completed, yeah, you would need also payment processing at the same time. And then you may, after the payment is successful, right, you will get some notification, and maybe logistic module will be there, which will start delivering the item to the address of the buyer, right? So they will see if there are so many communications, right? So there was one challenge, which was probably these services now we can scale. Definitely we decided that product catalog is something which will be most popular service out of all of these, because say a new iPhone gets released, so thousands and millions of users will be looking into the details of iPhone, but yes, few of them will be buying it, right? So maybe if we have say 1 million users or 3 million users looking into iPhone, maybe 1 million decides to buy it, right? So yes, maybe shopping cart may not need that much of a scalability. Product catalog may need more scalability here, right? Then, so what we can do is we can have more instances to serve more traffic. Clear? So we may decide that yes, order processing may also need some more servers, maybe 5 servers here, maybe here 10 servers, and maybe here 20 servers in the product catalog, right? And finally, few people will be paying, maybe some people are doing cash on delivery also. So even payment processing may be even lesser useful than the order processing. And yes, once your order is processed, you may have logistics, and you may also scale independently inventory management module, right? So you may have different number of instances for all these services. This is clear, right? Now the problem what comes is, if few servers are down, right, how will we deal with? Assume one instance of product catalog server goes down, right? You have many instances, so you should not serve the traffic to the server which is down, right? This can be taken care by the load balancer, right? So let me add a load balancer also to this picture. Yes, so this is the load balancer. So what I will do is I will have a load balancer. We also discussed about what are the various load balancing strategies. We may call just the load balancer. And yes, you need load balancer for each of these services, right? You need, so that, because yeah, you will need, because you have multiple instances and maybe various calls also. So basically you will need load balancers for each of these services, right? So, so that they may connect with each other. Yes. And if load balancer, if some instance is down, load balancer knows about it and it will be able to redirect. But here, yes, one problem we faced is each of the service has to know about other services. So that's another complicated thing. A few more things which we discussed was about the database. We can have different databases, right? So let's say we have a database for logistics. Yeah, you need to have different databases. You may have common for some microservices, but better to have all the microservices having different databases, right? So, and also, we also discussed that these microservices are easy to develop. They can independently developed by teams. right? Various teams. So let me get the teams also here who are working on this. So yeah, this is the team who is working on the product catalog, right? Basically, this is developers, dev team, yes. And there could be some other team also who are working on, say, some different servers. Maybe, yeah, we have few teams where only one person is working, right? Maybe, yeah, you have different different team sizes, basically 1, 2, 3, 5. They can independently work on each of their components, right? And when they change anything in their services, only they need to make sure that the interfaces are working well. The logic they can keep changing, right? So this provides a lot of flexibility. You may have different versions of different servers, these different services, and testing can also be done very easily because you have the team who knows about this testing of inventory management, for example, and then they can very effectively test this. And changes are only done in inventory management. If something is changed in inventory management, other components can just remain intact. Maybe they have to test the interfaces, but yes, other than that, nothing more they have to test. So testing is easy, deployment is easy. They can kind of work in very effective manner, fast manner, deliver the product, deliver innovations, much better manner, right? But few challenges are there. As I said, these calls are basically web services calls, right? So all these calls are web services calls, and these servers could be in the same location. Mostly it will be in the same location, but you may have it in different locations, different geographies, different data centers as well. So that's also flexibility. But yes, you have to ensure these connections are fast, right? Because since there are so many hops, if your connections are not fast, then you will have slower response time in the UI, right? Now, we added one more layer because we had some problem, like authentication, for example, has to be implemented in all the modules with this, right? So assume this is the authentication module, right? Let me write this as A. So yeah, if you have to implement authentication, you have to write this same thing in all the places, right? Which is cumbersome, right? There are some advantage also. Say, I'll give another example. Maybe if you have implemented, say, some service for logging, right? Let's say we implemented something for logging, or let's say we implemented something for, say, search, right? Now, this search, if I create as a microservice, then this is providing a lot of flexibility because no, it can be used to search for products when product catalog calls it, right? So yeah, maybe I should place it somewhere near product catalog. Yeah, let's say here, right? So yes, there are various benefits of microservices as well, because sometimes it can promote reuse also, because everything is as a separate service. So many of the business functionality can be shared. So now if you want the, if someone wants to implement search engine, for example, let's say inventory also wants to have a search, they can directly use this search service, right? So this is a specialized service, and this is the way you can have a reuse also, right? So this is how you can reuse the services, because all the services are independent component. If you design it well and design it in a generic way, you can reuse it. This also minimizes the effort also. But yes, sometimes you may have to also have duplicate code, because, for example, authentication has to be implemented in each of the microservices. Yes, right? Because now we have more services also. So you may have one load balancer. I'm coming to that, right? You need multiple load balancers, right? So because each service is a different service, right? Correct, right? See, yeah, actually what will happen is there are different ways you can implement it. Yeah, this thing. So the one way could be, generally that's how things done. We may have, right? So yeah, these are various microservices directly connecting to the client. Yeah. Yes. So now last time we discussed about API gateway. So that I will again discuss here. So let me add the API gateway. So here there is a challenge here, which is rightly figured out that there are multiple load balancers. And then let me introduce now some new component, because that is one thing which we can do to improve it. So we will be discussing about the API gateway pattern. So we discussed already last time. So what we did was we implemented a API gateway. Let me get API gateway also here. Let's say from here we get API gateway. So our API gateway was like a gate. Yeah, this is the API gateway. So we have the API gateway, right? So that would be a good way to architect our system. Let me move things a little bit so that we can place everything properly. Yes. Yes. Right. So what we will do is we will add an API gateway. Yeah. So rather than everyone calling individual services, because that would be very complicated thing for the clients, because you may have different client applications also. Maybe you will have iOS client, you may also have Android client also, right? And you may also have, you may want to use this from various clients, and you may also have a browser-based client also, right? So yeah, let's say this is your another client, which is some web client, right? So this is very challenging, because if you have to call different web services from the client directly, then this is very complicated. So we introduced the API gateway. With API gateway, what it can do, it can take care of various aspects. It can make a call to different services. So what it does the routing, right? And there are definitely multiple clients. So it is also doing load balancing, right? So right. And then you have, but yeah, still you would need here, you need to have the load balancing for each and every services. Now, yeah, the API gateway can do the load balancing from the client to various requests, and then it can also act as a load balancer, because since this is connecting, so API gateway has this inbuilt capability of load balancing, right? So in this case, you are directly communicating with API gateway, right? Now, rather than individual services calling, so yeah, you see here, this API gateway have this functionality of load balancing, right? So rather than now services calling each other, what they can do, they can make a call via API gateway to order processing service or to any other service. So now they may not talk directly. They will all communicate via API gateway, right? Because all the APIs are present here. API gateway is aware of all the APIs and it will be routing the calls. So see, the clients are not only your mobile front end, but client applications could be other microservices also. So other microservices also acts as a client, right? So in this case, you will be able to also remove all these connections with connections via API gateway. So this is one pattern which helps you a lot of things. And what you can do is you can also implement authentication in the API gateway, right? So now you don't have to put this everywhere. You do this in API gateway, right? If something is authenticated, all the calls are going via API gateway. So you will be able to authenticate, and in case authentication is successful, then only you make a call, route the request to the other services. We discussed various other functionalities of API gateway as well. So the other functionality is logging. Logging could also be added here. Monitoring, tracing, a lot of things you can have in the API gateway, right? You may have a lot of caching also could be done, right? So there are various features I provided in the last session, list of various features in the API gateway, right? With the API gateway, you also get load balancing. You get to know about various services. So API gateway is aware of all the services and it can redirect to all the services. But yes, again, here you see this has become a bottleneck. This could be a single point of failure. If API gateway is down, then everything is down. So you may also want to run this in cluster, right? So you may have multiple API gateways to ensure that everything is working properly, right? So this way you will be having reliable, available application, right? Still, there are more challenges, right? Because API gateway is doing caching, so now every request is fast, yes. But it may happen that, yes, assume servers are down, right? Assume the entire product service is down. All the instances are down. That may also happen. So in that case, you would also need some health checks, right? So there is another pattern which I would like to discuss, which is about health checks, right? Does anyone know what is health checks?
Maybe it will identify server crash or something like that.
Right. So yeah, health check is a service. What it will do, it will
resource utilization
service to check if it's up or it's
yes,
down.
yes, right. So maybe you may call every 10 seconds all the services, whether they are running, and health check is a service which will be implemented in the API gateway. Basically, you need to provide information about the health. So yes, health check service will be requesting or health of each of the services at a regular interval of time. It will be aware of which all services are up and running, right? Now you see there could be more problems again. So assume your payment processing is down, right? Let's assume all the instances of payments processing is down. Yeah. right? So this service is down. Now it does not make sense to take the order processing because orders will all fail, right? So what will happen is if payment processing is down, maybe there was too much of load here, payment processing, and all the instances crashed, right? It could happen. The load increased so much that all the instances crashed because one crashed, then second crashed, and everything crashed. Now payment processing is down, so order processing will also not work, right? And here it also some failure will start happening because payment processing is down. So it may also happen that eventually order processing also starts getting down, right? Because of there are failures in some other service. Just I'm giving a hypothetical example. This can happen in various scenarios, right? So what will happen is your, okay, so let me try. Yes. Right, so order processing is also down, right? Can happen because yes, because the payment processing went down, so then order processing also goes down. And since order processing was down, right? Anyway, shopping cart, adding items to shopping cart, maybe it is useful, but yes, order processing does not make any sense. So what you should do is there is another pattern which is called circuit breaker pattern, right? So circuit breaker pattern is a pattern in which what you will do is you will remove this connection if there are some problems down the line, right? So this is another interesting pattern in microservices because yes, it may happen that because some service is down, right? So for example, search service may be down. So if it may lead to some other problems also. So it may happen because all the microservices are dependent on each other. So that may happen that you may not be able to fulfill the request of other services also if one service is down, right? So then in that scenario, best approach is to implement a circuit breaker, right? Circuit breaker is a code. Again, this could be implemented via API gateway, right? This is a feature of API gateway. What it can do is it can disallow all the calls, basically all the calls from shopping cart to order processing is also happening via API gateway. So you will have the capability to implement circuit breaker also in API gateway, right? So health check is one thing, load balancing is another pattern, and circuit breaker is another pattern. Clear? Now, other important thing is how will the API's gateway know about all these services, right? So that is called service registration. Right? And service discovery. So what actually you have to do is anytime you are creating a new microservice, you should also start registering the microservice to the API gateway, right? This is called service registration. Anytime you're instantiating a new microservice, it should do registration with the API gateway. This is service registry, right? So what actually service registration does, it gives the IP address of the, so probably you will give the details of the service, right? So IP address, port, base, definitely starting with the name of the service, IP address, port, etc. for the service, so that now this service can be located, right? So assume we added product catalog service. So these details will be added to the service registry. And service discovery is nothing. Service discovery is the process of finding an entry in service registry. So this is service discovery pattern, right? So now every call is happening via service discovery pattern. One is product catalog is making a call to shopping cart or maybe to order processing. So what it will do, it will go to API gateway. It will check about the service is in the service registry, and API gateway will provide the details of the service, and it will make a call, and then you will have the service discovery. This process is called service discovery, and this way even you can discover new services and make a call, right? It's a very interesting pattern for UI also, because if you add more, say assume you have various options for a product, and now maybe you support sharing a product image with some mobiles, right? Mobile apps. Say, for example, you want sharing with WhatsApp, sharing with Gmail. So yes, in that case, what can happen is you may keep creating new services. Maybe share with Facebook is a new service, share with WhatsApp is a new service, or check prices from other stores, that could be another service. So as these new services are coming, you may automatically dynamically populate buttons, controls in the UI. So this way you can have a UI which can be automatically extensible when there are new features, new services available in the backend, right? Again, service registry are two types. One is the client-side service registry and server-side service registry. So in client-side service registry, you have to take care of service registration. So client has to make a request, and client is responsible for maintaining the services, list of services. And in other case, in the server-side service registry, you have to, the server takes care of maintaining the list of services. So this is pattern about service registry. Right. So basically, service registry is a component of API gateway, or you may have a server. So basically, it's a service. This is service registry. Right. And whenever you are making a call, so client is making a call to the API gateway. What API gateway does is it checks from the service registry what is the endpoints for this, and based on this, it will get the endpoints, and then it will make a call to that particular service. So this is how call to a particular microservice works. Did you got the you got about how the service registration works, right? Great.
Hello.
Yes.
I did not understood how we are doing service registry works on client side.
Okay. Okay. Sure. I'll explain that part. Give me a minute. Yes. So there are two kinds of service registry. One is client side service registry. Other one is server side service registry, right? So difference between this is, in this server there is a server which is responsible for maintaining list of services and their endpoints, right? In the client, it's client's responsibility to maintain list of services and their endpoints, right? So
my question is, I'm client, and let's suppose I'm using Amazon application. So where do I maintain the registry?
yeah, right. See, you don't have to, again, this will be implemented in the infrastructure side. But yes, either service registry can happen in the server side or it can happen in the client side, right? So whatever is there in the infrastructure, they may be using server side or client side service registry. You will have to do accordingly, right? You don't have to create yourself the service registry. Service registry is the feature which will be provided in infrastructure, right? So here, only thing you have to remember is client is responsible for service registration and querying the service registry, right? And in this case, what we have is we have a dedicated server which is managing the service registrations, and it is providing the location of all the services. So this is server side service registry, right? In client side service registry, what actually happens is there's no central service registry. What happens is each service maintains its registry, right? So what can happen is each service may have one registry where it maintains what all services are available, right? So mostly we use the server side service registry. And there are a lot of tools available. So you can implement using various tools. One very popular tool is Console, which can do service registry, right? So either the same Console tool can be used for service registration, right? Let me show you also the tool. What does the Console tool does? So how does the service registry looks like? Yeah. Okay. See, I have this service registry, right? So I have few microservices running and there are multiple instances of it running. Yes. Now let me do one thing is so you see here, this is a console tool. These are the list of services. When I click on the services, I can get details about the service, which is what is the location, right, etc. You will get here. So let me now see, services are not running right now, but let me start the service. So let me do this in front of you. So I go here. Okay, I have a microservice here created. I will be running this microservices. I'm just giving the maven command to run this microservice. This is a Java based microservice which I have created. I will run this. So now I've given the command, so it should execute it. Right. So see, this service is called gamification service. And in this service, I have added the dependency for registering. So this is programmed so that whenever this service will be up, it will register to the service registry, right? So what will happen there? Here I have also implemented health check as well. This is console. Console is the tool which is this running. This is the service registry. And yes, after some time now it will do the check, and automatically once the service is up and running, it will register itself to the service registry, right? So if I look into now the details, what is happening here, it is initializing the service, started the service. Right. So let me run another instance of this also. So I'm running the same instance again in the different port. So what actually happens is once the service is up and running, it will update itself in the service registry. So this way it knows whether the services are up or not, right? So and then in the same way, I may run also the other service. So it will update itself once the service is up and running. So let me see what is the status in this service. Yeah, still it's in the starting stage. So let me see what is happening. If it starts, then it will register itself, right? So this is how basically, you do create a microservice. Microservice will be aware of the service registry, and whenever you will start your microservice, it will, once the service is started successfully, it will register. So maybe I'll come back to it once it is complete, right? If the service is started and then it's registered, then I'll show you what will happen. You will see that there will be instances, other details coming up, right? So this is how the service registration happens. So you saw that this tool, this is the service registry, which is nothing. It's a simple database where you have number of services and what is the status of each of the service. And what it does, it also do the health check. So there is an interface, and this is the interface which this service implements. And in this interface, the health status is available for this particular service. So what actually happens is this keeps pinging every 10 seconds. You can configure how frequently you would like to do the health check. And basically it will start pinging the service and update the health check, right? It can do the load balancing also. So this tool, this is about service registry. So while you are initializing your microservice, what you do, you register to the service registry. So this is one process how the service registration happens. Now, this component, you can have it as a central component, right? If this is a central component which is used across all the microservices, then this becomes a server-side server registry, right? So it is server-side service registry. This same component you may include in different microservices. So for example, if you know that, yes, I just want to communicate with some number of services, maybe you maintain your own service registry also. So then this becomes a client-side service registry. So there is no centralized service registry. There are many service registry where the services are getting registered, and then you will be able to communicate with each other. So this is difference between client-side and server-side service registry. Right? But yes, this process, you just remember that whenever any new service is initializing, it will register to the service registry. So this is about the service registration pattern.
Let's suppose like I'm having one service which calculates addition, which does automatic calculation. Okay, so if
Yes.
I want to use in my application,
Yes.
so I have to with the help of service discovery, I have to register that service.
Yeah.
Like
Yeah.
I can use any service.
Yes. Yes.
And in the service registry, what are the things we should have? IP address, port. That's
Right.
it.
Right. Yes. Absolutely. Absolutely.
Like
Right.
the way we do in
Yes.
distributed
Yes.
system, like in REST template, we pass API URL.
Yes, yes, correct, correct. Yeah, just a minute. Let me share you even the source code details so that it becomes more clear to you what actually happens in the service registry, service registration, right?
Mhm.
So basically, you have to understand that there are components, and in a lot of frameworks, whichever is used to create microservices. In this case, I'm using Spring for creating microservices. So I have the application properties, right? So here, what I do is, if you look into this, I give the application name, right? So this is my application name. This is important. And this is my server port, which is the default server port, right? I have the database. Now, how I am enabling this to make it register in the service registry is, I'll share. So what actually I do here is, in the file, I have here a component, which is, I include here discovery, right? Service discovery. So when I put this console discovery, automatically this service will get initialized and it will be talking to the console module, which will be registering this service. So yes, you don't have to manually put all the details. This is done by the framework. So whatever is the required details, this will be taken. For implementing health check, I just need to add this dependency. Automatically for my service, the health check is enabled, right? So this is how I will be implementing health checks, or I will be implementing service registration in any of my application microservices, right?
So maybe like I'm asking many questions because I joined in between. So like there is a message queue and this. So this is different.
Yes, this is different. This service registration is different. This part of API gateway, right? I'm going to cover message queue next.
Okay.
Right. So basically, yeah, you just have to think of it's like a telephone directory. So you have so many services. So you may be it will be very difficult for each of the individual services to remember their addresses, right? So what is the best way is to do this we using another service, which is a service registry, and that takes care of having the information about where to connect with. Right. So yes, this is about service registry. So we covered health
So
checks.
what is the advantage of this kind of service registry? And meaning like okay, we are achieving microservice architecture. Okay.
Yes, yes. In microservices architecture, you will have so many services, and these services will dynamically change their address ports, right? You may be adding more flexibility. Flexibility is the advantage because you can't know how many instances. Basically, you need a central place where this information is there. How many instances for a particular service is available, or which port and which host a particular service is available, right? Because there could be new services which will be coming in. There could be also changes in existing services. So you don't have to change your microservice. All these changes is done in the service registry. So then that becomes very easy. You don't have to worry about what is the port, and you don't have to know about the details of other microservices. So that's the advantage. Okay, sure. So I'll move on. Yeah.
Two, three more questions, sir. Like it's a e-commerce application, and if I am adding one more service on it,
Yes.
so I don't need to notify anyone. Like I am going to add one more
Yes.
service.
Yes, absolutely. Absolutely. Right.
And time to time, it will automatically refresh it and understood.
Yes. Yes. Right. So yeah, so assume you are working on logistic service. You kill one server instance and you add more instances. So this you don't have to communicate to everyone other, because if there are 10 different services which are consuming you, then you don't have to tell to each of them that yes, I'm changing my port or I'm changing my host name. Automatically this happens because when you run this new service, it will initialize, it will put its detail in the service registry, and the code always makes a call to the service registry, and then it makes a call to the service based on the endpoint it has returned. Yes, so this is the advantage.
So like in the microservice, I also read somewhere like if some of the application is not working,
Yes,
in that case also the application keeps running. But how does that happen actually?
yes,
If the
yes,
let's suppose example of Amazon, let's suppose
yes,
the
absolutely.
payment
Yeah.
service is not working. Then
Right, right, right. Yes, see, everything is a different microservice, right? So assume payment service is not working. That happens a lot of times because you might have encountered when you are trying to pay, maybe ICICI Bank is down or the payment is down.
Mm.
So you are not able to process. They show a message saying they show a cute dog and says they show a message saying that please try
yeah.
later because of more load or because of various technical issues that can happen, but it does not stops the entire application. And in the last class we discussed, because the application is running as part of multiple microservices, so you'll be able to do the search, product search, because that is a separate microservice. You will be able to view the shopping cart because that is separate microservice. There's no impact on that, right? But only the payment processing service is down. So maybe you will not be able to do the payment, right? And if it is a temporary down, also microservices implement another pattern, which is called retry pattern, right? So retry pattern is nothing. This again could be implemented in the API gateway also. You say, in case a service is down, please make 3 retries. You may configure that. Yeah, always retry 3 times. And if it returns the value in any one time, then you use that information. But yes, if 3 times it fails, then you mark it as down and you can return the error message, right? So this is various patterns which can be used to ensure that your entire application does not crashes in case one component is down, right? So basically you design that all the microservices should be aware that the other service may not return the response. So in case no response is there, you just show some message saying that no, this service is not available. Please retry, and once it becomes available, then that feature will be available. Otherwise, until then, this feature will not be available. So this is about the retry pattern.
So every configuration would be done at the API gateway level.
Right. So see, I will again repeat this, right? So in this case, let's take an example again from scratch. You have a mobile application. You have multiple services, right? Let me write these services. There is one service which is shopping cart service. There is one service which is product catalog service. Right? Just I'm putting it again and again. Then let's say there is another service which is order management service, right? Just for, and there may be many more service also similarly, right? So yes, let me say ... for that. Right. So yeah, this is individual services. Now, what actually client will do always, we will implement here a API gateway, right? API gateway, correct?
Gateway
API
to
gateway,
all the services.
yes, right? Whenever a new service is up and running, so assume you are setting up this environment, you started the product catalog service. So when this product catalog service is up, it will register itself to the API gateway. So this is service registration process.
And where will do that API registry things? That is also at API gateway level.
Yes, right. So API registry is a, so see, API gateway is a, you can think of as a middleware, is a big application, big software. It has many features. So it has service registry, right? This is one feature. There is other feature also, other features as well. It has
Okay.
caching. Yeah, I talked about so many things. So all for all of them, there will be different features here. So I talked about logging, monitoring, caching, right? Authentication. So there could be many features in API gateway, rate limiting, all these we discussed in the last class. So first thing is this service registration will happen. And now the client calls, right? See, now these two services are not yet there, right? Client calls, it will get the details about product catalog. It will make a call to product catalog and it will show the product catalog. After some time, so yeah, if some user clicks on shopping cart, it will not see any data. It will say that the service is not available. But yes, now you will restart this shopping cart. So once shopping cart is there, the service registration of shopping cart will also happen. API gateway will know that this is the endpoint, right? Maybe this previous server was, there was some hardware failure. So you set up a new server, right? Now this information is automatically updated, and every time the client is doing service registry, so it is retrieving this information again. So automatically the new IP address is updated with this client and it will be able to call shopping cart. Yes. So it will be able to call it. Now, yeah, it will do also health check. So that's another feature, right? Once the service is there, we may start doing health checks. We may also have here circuit breakers, right? Because some services may have a cascading effect. For example, I gave that if payment processing is down, let's say we have a payment processing, the ordering will fail. Right? So the better approach would be client clicking on order and then seeing an error message when after he has entered the credit card number and all. That may be bad user experience. So what we can do is we can implement a circuit breaker. Anyway, we are doing the health checks, so we know which services are up and down. In case this payment service is down, we may have a logic that please block the calls to the order service also, right? So we are making purposely this service unavailable because this service depends on this service and we don't want unnecessary errors and failures here. Right? So yeah, each of the services are again client here, and then they will be calling through service registry only other services. Correct? So this is how this API gateway works. So this is called, this component is called API gateway.
So API gateway is very crucial in Microservices.
Right. It is very crucial because there are multiple products which are API gateways. Right, almost all the providers, all the software vendors, they have their own API gateways. Yes. Now, one more feature of API gateway. Yeah, there are so many patterns. Let me talk about aggregation. Right, this is called service aggregation. What does it mean? Right. So assume we have a service which is display product details, right? Now, when you display the product details, you need the product photo, product descriptions, various other details. But maybe there is a separate service which is inventory service. So yes, everyone pay attention. This is called aggregation pattern. So rather than client making two requests, right? One to get a call to product catalog and other to make a call to inventory service, you may create a fake microservice, which is internally making two calls to two different microservices, aggregating the data and returning the data to the client, right? So this is another pattern, which is service aggregation pattern.
What is so it's a fake microservice you're saying?
Pardon?
Uh,
Yeah,
no,
you can say it's a service. It's a service. Aggregation means you are getting data from multiple services, aggregating it, and then returning it to the client, right? So you are doing aggregation of information here, right? There is
okay.
no such microservice. It is an aggregation service. The real work is done by these two services, right? So when you say, get me the product detail, so real work is happening in this service, which is product catalog, which will have probably some details like details of product. And there is another service, which is inventory service, which has, you say, the stock and price, right? Okay, price, discount, etc. You may have here. So some information is coming from inventory service, some information is coming from product service. So here the call is get products, right? This is the call which client is making, or maybe say, let's say get, products. Internally, it is making two calls. One is get product from catalog, and then it's making another call, get inventory, right? Get product from inventory, right? Say these are two separate calls. This is happening, right? If you had a monolith, right? Basically, what you will have is, you will have here another database. Let me draw that again, a database. Here, right? So you have, this is a database. As I said, in microservices, each of the services will have separate database. So you cannot access this database directly from this service. So there's no way of doing joins, right? So joins cannot be done, but yes, what you can do is you can do aggregation, service aggregation. This is one way of implementing joins, database joins in microservices architecture, right? And now this API gateway is becoming a bottleneck for you, because it could be a single point of failure. Because what if API gateway is down, then nothing will work in your application, right? So what you should generally do is you should have multiple API gateways, right? Maybe you can have, say, one API gateway for mobiles, right? Mobile clients, one API gateway for web clients, and maybe you may have different API gateways also. This way you will be able to reduce the risk of, you can have a cluster of API gateway as well. This way you will be able to reduce the risk of everything going down, right? So hope now all these patterns are clear, right? Caching is clear, how it could be done in API gateway. Health check, why it is important. This is another thing. Health check, because health check you need to do Say, for example, when you're doing health check for a product catalog, you have to do whether the service is down or not. And you should also do health check of the database, whether the database up and running. Because anything, if it is failing, assume the database is down, then also you give the health check for the product catalog service as down, right? And there may be more components as well. If suppose you have file server also here, then the health check will also do the file server check, and in case anything is down, it will mark this entire service as down. Right. Same way, when you are adding a product, right? So assume there is another mobile app which is adding the details of a product. You can again use the service aggregator pattern, because not only for reading, for writing also, when you are adding a new product, you write to the catalog, update all the details about the product, and at the same time also write to the inventory, update stock, price, discount, etc. Right. Now, one more important thing, one problem you may get here. Assume order service is down, right? So all the orders which are made will get lost, will not be processed, because order processing is done at this microservice. This will be loss of business for the organization, because orders are now lost, because service is down, so it could not be processed, and if it could not be processed, it will be lost. So what you can do here is you can create a message queue, right? So the next pattern which we will be discussing is about message queues. Let me get a message queue here, this message queue. So what you can do is you can buffer all the orders, right, in the message queue. And order processing service will always read the orders from the message queue. So let me create another diagram to make it even more clear, right? So we'll cover in detail the message queues, because this is important thing. See, there could be two scenarios. One, there are too many orders and the server is overloaded, so it will not be able to process every request. In that case also, you will lose some requests. Or if server is down, then also you will lose the requests. So the best way to go ahead in this case is to implement a message queue. Message queue also helps in asynchronous communication, right? So there are another use case. So one use case is, let me start here. So you have here, say, shopping cart service, right? Shopping cart service, if someone makes an order, right, there is a order processing service. So orders will be stored in the message queue, right? And one scenario, this is order service, right? So this is how, actually let's assume this is how it works. You have here a client, mobile client. This is your Amazon app, let's say, right? This is e-commerce app, right? So basically, yeah, you have an API gateway with a lot of features. I will not draw again all these features, but yes, you now understand well what API gateway provides. Now from API gateway, service discovery happens, and then this call will get routed to shopping cart. Yes, shopping cart is displayed in the app. User does the ordering from this shopping cart. So shopping cart status is updated to ordered. So what you can do, you can trigger an event, say order created, right here. Right, one event you can create. There could be a topic in the queue, which is we call order topic, right? Orders. Let's call this orders topic. So this is basically nothing but a classification of messages, and you create an event called order created. In this event, you have product ID, quantity, that's all, right? Now, assume order service is down. No problem. You will get more and more events or messages. Both are same thing. Events and messages are almost same. So let's say this is product ID 1, quantity 2. Then there is another, someone else also created another order. So same, maybe some other details are there here. Say you have product ID 2, quantity 5. This will also be stored in the queue. Once the order is up again, it will read this messages from the queue. And these messages are never deleted. If assume it is able to process this, it will mark this status as completed, right? Or processed. There could be many states. So it will keep updating the states. Now, what could be the other scenario? It comes up, but when it's trying to process this, it got some error, right? And it crashed again. So in that case, if you don't have message queue, you will again lose the order. But in this case, the message will still remain in the queue. You will definitely not update the status. So once you are back again, you can retry this order processing, right? So this is another use case. So two use cases I covered. One is in case while processing the order is not processed properly, then also you don't lose the order. And if the service is unavailable while the order was created, then also you don't lose the order. Right? Now, there is a third scenario also. So assume order processing has to communicate to another microservice, which is payment. Right? So order processing makes a call to, again, API gateway. But yes, this is normal scenario now, right? Since now you have a queue, rather than, yes, what you can do is order processing. Yeah. In other scenario, what will happen is, yes, you will make a call to API gateway. Maybe there is another API gateway. As I said, better to have multiple API gateways. This way, you can ensure that your services, there's no single point of failure, right? So just for simplicity, let's assume, or it could be the same API gateway, or it could be a different API gateway, right? So assume order processing again makes a call and then gets the details about payment processing service, and then it makes a call to payment processing service. And this payment processing service is verifying, doing a lot of things. So it takes 5 minutes. Yeah. Now order processing is waiting for the response, right? So it cannot do anything in this 5 minutes. because yes, maybe 5 minutes, or let's say now things are very fast. Even if it is say taking say 30 seconds, which is definitely reasonable, it will not be able to process more requests in this 30 seconds until payment is completely processed. Because yeah, payment processing will make a validation call, maybe do fraud detection, and once everything is verified, it will check with the bank account and will transfer the money. And once the transfer is complete, then it will confirm the payment, and it will then reach to order processing that the payment is confirmed. But in that 30 seconds, it will not be able to do anything. So you need here more and more order instances, right? Which is a problem. You will not be able to effectively utilize your resources or servers. So what is the solution? Anyone?
One more message queue between gateway and payment.
Right. So what you can do is the order processing service, once it verifies that the order is correct, it can just update the status, right? Say payment pending, right? Maybe it can also put the amount. What is the payment to be done? So it just writes back in this message queue only, right? Now, see here, this is observers. Order is consumer of message. It's also called observers. So they are not waiting for some call to come. They're just waiting for the messages to come, and they are observing the queue, right? Or these are also called as consumers. Again, same thing, right? So it's observing, but yes, it is also producer also, because it's producing message for the payment. Once it marks anything as payment pending, maybe the payment service can take this message and process the payment. So payment service will also read and write the messages, right? So this is one way of dealing with this. So what payment processing can do is it can just mark this. Once payment is processed, it will say payment completed. So yes, what order service can do is just can write these messages and then move on to process the next order. Need not have to wait. When this will be updated, it can come back and process it and make a call to shipment service to ship the order. So this is about message.
That is acknowledgement mechanism, right?
Yeah, it's not acknowledgement mechanism. It is just consuming and reading, writing to the same message.
Okay.
Yeah. Basically, you can do this with a common database also, right? But databases are slow. Queue is something you may have messages, and messages may be categorized in the topics also, right? So basically you are creating new events, right? So here we have various events. So you should talk all these in terms of events. So we had the event first is order created, right? From the shopping cart, if someone clicks the order button, you have an event called order created. Appropriate details will be placed in the message queue. Next event is payment pending, right? So this maybe the user enters the payment details, mode of payment, and order is verified that this is a genuine order, right? Maybe now this order processing service will trigger another event once the verification is done, that payment pending. Now, once payment pending event happens, payment service will get notified. And payment service will take, okay, what all payments are pending. It will start processing these payments based on the details which are available. And once this is completed, it will fire another event. Or maybe it can have multiple events. One is payment processing is started, right? So payment is under processing. So this is just in case, no other, because what can also happen is, again, there will be multiple instances of payment services, right? If it does not mark it like payment processing, it may happen the same payment can be processed multiple times. So customers' money will be deducted multiple times. So what you can do is you can have a state called payment processing. And then finally, you can have a state where you have payment processed or completed, right? And then finally, you may have other states also, which is like shipping or item shipped, right? So all these apps, they work with message queue, and there are various states, and based on these states in the message, these are also called events. Different microservices will take different actions, right? So no calling each other, no waiting for each other, because if you call each other, you have to wait for the response also. But yes, here in the message queue, you are just updating the events, and based on the events, different microservices are taking different actions. This is called event-driven architecture. Is definitely a different approach to design your application. But here, important thing is you use message broker, message queue is all same thing, right? They are also called message broker. They are also called message queue, right? And example of this is Kafka and RabbitMQ. These are the two popular message queues, right? I'll give another example for message queue. We discussed in our previous session chess application, right? Yes. Right, so let's get the chess. Okay, assume we designed this game, chess game. Okay, it's too big. Let me get a small one. Yeah. It's coming big, but yeah, I can reduce the size of this. So assume we designed a chess game, right? So this is our chess game. Could be any game, right? This is also used here. You have a user, right? You have multiplayer game. This is a multiplayer game. So maybe there are multiple users here. User 1, user 2, right? So let me name it also user 1, user 2. This is user 2. This is user 1. And your game can be played by hundreds of players, because there could be multiple instances of the game which could be getting played at the same time, right? So there will be thousands and millions of players who will be playing different games in this game application, chess game, right? Now you have a service. Assume you have a service which is your, let's call it chess service or game service, right? So based on the moves, right? So users will move, and based on these moves, what game service does is it will decide winner, right? And if game has ended, it will decide winner. So again, what you need to do, if some winner, you have to generate the scores, right? You will have a scorecard, right? And scores will be for lifetime. So if say player wins one game, the service will say win has occurred and the scorecard needs to be updated, right? That this got 10 points, right? Tomorrow he'll play one more game, he'll get 10 more points. his score will become 20 point, right? Or it could be scorecard or rating service. You can call this ranking or rating or score, anything, whatever is the kind of game. You may also have a leaderboard right here. Leaderboard will display the top 10 leaders in maybe top 10 players ranking of players who have won most games. So what you can do is you can again implement this as a event queue, right? So you, rather than game service talking to this service, ranking service, because see, if everyone is talking to this service, it will get a lot of requests. So problem is, because see, millions of players are playing the game, so every millisecond some person would be winning and you will get a lot of calls. This service will get bombarded with a lot of calls. And leaderboard, people will also be viewing leaderboard. So leaderboard will also be bombarding. Yes. So the best approach is, rather than this service getting bombarded, let's create a message queue. And once the win occurs, you just put a message, win, right? Say user 1. Now, when this happens, the ranking service can pick up this message asynchronously and it can update the scores, right? And that means it can generate the leaderboards, right? So basically it may be maintaining a database, and in that database, it will be having scores for all the users. And basically once, these scores are updated, you can always read these top 10 from this database to generate the leaderboard, right? So basically, you will have here messages, various messages for all the wins, and ranking and scoring service will be updating the scores. This is one advantage, right? Now there is another advantage of this. This is a microservice architecture, right? If I create this scoring system in this service itself, then it becomes a monolith, right? Yeah, and then you don't have that scalability because you don't have flexibility here, right? Because here maybe game service, you need more instances because games are being played about, new game may be starting every 1 minute, every 1 second also. But the completion of the games may be happening, right, in some different intervals. Maybe some people are not completing the game itself, they are just leaving it, right? So in these cases, you need a different scale for this service, score service, different scale for gaming service. So this is one advantage. Assume there is another advantage of this approach. Assume you create tomorrow one more game, right? So let's say this game is a Ludo game. So you have a Ludo game. And so I'm just trying to draw the Ludo game here. Yeah, so something like this is your Ludo game, and you have here this Ludo, right? It's looking like Ludo board now, right? So a little bit size adjustment I can do. Yeah. And yes, these are your 4. Just right. So this is a Ludo game, right? Tomorrow, maybe multiple players are playing. You can still use the same scoring service and generate a different leaderboard, right? So this way you don't have to recreate the same logic again and again. you should always think of microservices as a service which can cater to multiple applications, right? Not just for one application. So now you may create more and more games fast, and you may have a very good scoring system, which is accurate and which can generate leaderboards also very well. So if you design using microservices architecture, you get reuse also. Right? So understood the benefits of message queue. Message queue takes care of, so here in this case, various applications, for example, Ludo, and this is chess, right? These are the producers for the message. And scoring app is the consumer for the messages. And it will be writing also. If someone else is also consuming, then it becomes a producer also for, and some other person will be consumer. So same microservice could be producer and consumer of a message, both it could be. Or you may have a microservice which is just a producer of message, or you may have a microservice which is just a consumer of message. So this is about producer consumer pattern or message queue pattern.
Which one is which? Yeah, you please go ahead.
Sir,
Yeah.
how long message will be there in the message queue, or when messages are removed from message queue?
Yeah. So messages will have a time to live. So they can be removed. You may have a policy. Say, for example, if you see that, okay, messages does not make sense. Say, for example, let's come back to the ordering app, right? If you feel that, yes, after, say, if an order is pending since 1 week, it does not make sense to just store it, right? Maybe everyone would have processed, even if they have not processed, okay, to lose it because maybe the item would have, the price would have changed, or item would have been gone out of stock, right? So you may decide based on your condition how much time you need the messages to store, because if you don't delete it, then you will run out of space, right? Disk space. So you can put some policy that any message after 1 week will be deleted, or after 1 year or several years, based on your requirement of the application. But yes, until that time, all the messages will be there. So this is, you can have messages which can be permanent or which could be deleted after a lot of time. Or there could be messages which can be deleted after less time also.
Yeah, there is the message in the message queue for longer time. There is a chance, right? Again, the consumer may pick up that message queue. Sir, message.
Yeah, yeah.
Oh, we can avoid it.
Yeah, that's what we discussed. Once consumer picks it up, it will mark the message that this is processing.
Okay, this
Yes.
in that
So
message.
this way, yes.
Okay.
Right. So I will cover that. So I am going to cover that in the upcoming topic. So just wait, I will be covering that also. Right. What actually happens inside the message queue. Internals of message queue, I'll take now.
Thanks.
Right. So let's take an example of the most popular message queue, which is Kafka. Right. So let's discuss about Kafka, what it is, and I will try to help you out to understand the concepts, how to use Kafka, when to use Kafka, and how it can help you in system design, and how can you present your design, right? So whenever you have this scenario where you can think of a publisher subscriber model, Or the other way is thinking about producer consumer model. Both are same. Yeah, just it's two different names. You can use Kafka, right? Kafka is nothing. You can use any message queue. And most popular one is Kafka, right? The reason why it's more popular because it is distributed message queue and it's very fast, right? So it is very fast because it can, this is also called stream processing, because basically what is a message queue doing? There are a lot of messages which are coming, right? So they will come one by one. Yeah. Right. And in a very high speed, it will come. It's like many cars entering parking lot, right? If you go to Forum Mall in Bangalore and on a weekend, you will see many cars almost, right? Every millisecond you are getting a car. And then at the same time, these messages are also getting processed, right? So you need, when you need real-time processing of stream of data, then you can use message queue or something which is also known as message broker, Kafka, right? And this is if you have to process billions of messages, right? For example, Amazon orders. Amazon is used all across the world. So you have billions and millions of orders which are getting placed every second, right? So that large scale real-time processing means if order is placed, it should be processed immediately as fast as possible, because if users are not seeing the confirmation, they will feel bad. The experience will not be good, right? So you don't get immediate shipment, but yeah, it may take few seconds, but yes, you get almost real-time processing of messages. Also, it should be fault tolerant, that no messages should get lost. It should be reliable. Fault tolerant means if it should not go, it should not crash, right? It should, in case some problem happens, right? So this is another term I will describe here because it's very important. So assume you have made an order, right? You have ordered an iPhone and this is your message. Let's say the first one. This is, you have purchased iPhone, you have paid 1,50,000. No, not, you have not paid, but your order is getting processed, right? So this is, and the margin for this is maybe 50,000. Amazon is earning out of this, and 1 lakh out of 1 lakh, maybe 50-60,000. Apple will be earning, and remaining amount, yes, would be the real cost. But yes, whatever, this message is processed, getting processed, and here is the order processing unit, right? But yes, there was a developer who probably missed one condition, if else condition, and because of it there is a bug. So when this order processing is happening, it gives an error and it crashes, right? Now message will still be there, right? If message queue would not have been there, then the company would have lost 50,000 rupees. And yes, they would lose many such orders, right? But in this case, what is there is, you have multiple, so other server will pick up, right? And this will reprocess it, correct? So you can do reprocessing also, you can do retry also. If there is some temporary issue, you can just reprocess it, and then this message will get processed And yes, you will also feel bad if suppose you ordered and maybe it's your birthday or you are planning to gift it to someone and you don't get the order processed, then it will be pathetic experience, right? Maybe you said to someone that yes, I will be gifting you iPhone, and then no, the iPhone does not arrive, and that moment then you will be in problem, and then you will say, okay, I'll never use this application. So this is advantage that makes the application fault tolerant. So if one fault happens, no problem, the application is reliable, some other application will process it, and some intermediate fault will not impact the processing of the messages, right? So this is also highly scalable, and it is also fault tolerant, right? And also fault tolerant also means that if some component in the system is breaking, right? So here in this case, maybe one component was breaking, but other processing will keep happening, right? Assume this, there is a lot of processing which has to be done. Maybe this message has to go to also IT department, this income tax department, right? So maybe there is a law that yes, whenever there is iPhone purchased, that particular person should get an approval from whatever, income tax commissioner. And once approval is there, then only iPhone will be shipped, right? So something like that, or any other tricky scenario, maybe some checks could be done. So in that case also, you may have various such scenarios implemented, and everything can work in parallel, and there is no waiting required, right? Parallel processing whenever is required, that can happen. And in case some components are failing, overall the system will continue processing this message, and whenever some component returns, the steps will be taken up accordingly. This also happens when you do video upload in YouTube. When you upload a video, it does copyright check, it does a lot of checks. Maybe it tries to identify whether there is any objectionable content, and it will also do encoding. It will create various formats, and right, the video will be encoded in various formats for mobile users, for HD, for full HD users, etc. So everything will happen in parallel, and message queue will take care of processing all these videos in parallel. And once the video is uploaded and all the steps are successfully completed, you get a confirmation that your video is published, right? So advantages are I covered already: real-time processing, fault tolerance, right? Scalability, right? And you have persistence of message also. Great. Someone got yes. So any questions? Right. So yes, maybe now we'll cover the details about Kafka in the next class. Someone snoring. He felt asleep. Is it? Please wake up. Yeah, you are all so hearing this.
Yes, I think Miss
Okay.
Ranjana is sleeping.
Yeah.
Okay. No problem. I'll mute that person. I will be able to figure out. No problem. But yes, okay. Next time we'll discuss things faster, and we'll cover Kafka in detail about how we can further configure the Kafka as per different scenarios. And we'll also discuss about containers. So that is another pattern which is remaining. But yes, we've covered many patterns in microservices, various ways to make the microservices most effective.
Will you discuss Saga also in next class?
Saga, okay.
Saga pattern.
Saga leadership election and all that. Yeah, we'll cover that. Yes.
Yeah.
But yes, I'll cover containers first, and then we'll cover all
Oh.
these distributed protocols of transaction management, transaction handling.
Also, I had doubt in message queue. If the server restart or shut down suddenly, then we lose all message, right?
Yeah, this is a distributed queue. Okay, so that means there's a cluster of, so basically what actually happens in Kafka is not a single server. This is multiple servers. That's why it's possible. So, and you will have the messages, one message will be replicated in multiple places, right? In multiple locations. So if one server restarts, no problem. You can have from other places the message processed. Right? So it does not matter if suppose some server restarts. You will have other messages in other place.
The sync will
Yeah.
the sync will happen automatically, right?
The sync will happen automatically. Yes, that will be taken care by the platform. Right? So it will take care of sync and replication so that the message will not be lost.
Okay.
Right. So we'll discuss that in more detail in the next class.
Tarun, how many classes are left?
We have around, I believe, should be Saturday and yeah, today is, I believe, yeah, there should be 3 classes left. 3 classes should be left.
Okay. After this class.
Okay, let me open my calendar. Let me see what number of class we are into. Yes. So we have a class on Saturday. Yes. So we have after this class 3 classes. Yes, exactly 1 more week is there. 3 classes are there after this class.
Okay.
Yes. So what we will be covering in the next class is containerization, right? And we'll be covering, yes, definitely Kafka message queues in detail. Right. So we are anyway halfway through the message queues. We already started it. And Kafka, right? Then we will cover system design of YouTube, and we can cover system design of Instagram, right? And in this, we can cover any further topic which will come in, yes, whatever related questions, queries, and doubts, any concepts which will come within these architecture classes, case studies will cover.
Tarun, like, can we have system design of some like real time, like let's say a live sports, Hotstar?
Yes,
that-
yes, right, sure. So yeah, we can do Hotstar, right? Because yes, Hotstar we can do. YouTube is also similar. Hotstar is more complicated because it's live streaming. So we'll do that, right? So because Hotstar also have a static content also, right? So
yeah.
Hotstar is YouTube, but YouTube is also live. So it's also same thing. Yeah. No, see, YouTube can also do live things. So it's same, right? Hotstar, YouTube, or whatever you can say. Netflix, right? So, or Sony Live, all these, right, will be similar architecture, right? Absolutely same architecture. Now, Instagram, Twitter, right? These will be similar architecture.
Yeah, and
Facebook, Facebook posts, right? These will be similar architecture.
one more doubt, in the Instagram and Twitter, are we also including the messenger app?
WhatsApp kind of app? Yeah, we can discuss that also.
Because we have WebSocket connections, right? That is different
WhatsApp,
connections.
yeah, WhatsApp kind of app. Say WhatsApp, Facebook Messenger, right? This we can also discuss. Right, similar design is there, right? Basically, yeah, we can discuss that. Messenger apps. Basically, you are asking about messenger apps.
Yeah.
This is basically newsfeed apps,
Mm.
right? So you see, there is a lot of similarity. But yes, in Facebook or WhatsApp also, we will cover, you can, yeah, don't worry about, say, video call, and also we may discuss briefly about it, voice calls.
Mm.
And there is also group calls, right? Then if we cover all this, then we will have something like Zoom architecture, right? This is also similar. And group calls basically is Zoom or Google Meet, right? So these things, these are various topics which we can touch upon. I can share some insights on these.
Yeah.
And the same process we can apply, and these will be high level design. All will be high level design, because low level design, can't design in low level Hotstar or Netflix, because then you have to write code for encoding and all that. But yes, we'll cover it from HLD. These are all HLD topics.
Yeah.
Awesome. Right. So yeah, this is about HLD. So yeah, maybe what we can do is we can take some more topics. So no problem. If you guys are not feeling comfortable about, collect your doubts, we can discuss it, and we can do few classes extra time also, right? So don't worry about exactly closing at 10. In case now, if we can extend 10:30. Yeah, now I understand you guys will be tired, but yes, I can plan 30 minutes extra and resolve your doubts also in the meantime, in next 3 classes.
Arun,
Sure. Yeah,
we have next 3 classes, right? In
3
these
more
next 3
classes.
classes, yeah, like you have listed Hotstar and newsfeed and video call, right? So we should be able to cover all these 3, right, in the next 3 classes.
Yes. So
HLD.
first class, this one class.
Hmm.
This one in the second class.
Hmm.
And what we will cover also is, let me do this. we will also discuss this part here. This part here. Right? Basically video call, Zoom and all, these are same thing, very similar.
Live streaming and video call are similar. Okay.
Yes, yes. There's slight difference. There's
Okay.
actually a lot of difference, but still a lot of commonalities as well.
Mhm.
And these two in the other class. So this is how the 3 classes will happen, right? So this is Saturday, right? And this is Tuesday. And this last one is next Thursday. So
Yeah,
yes.
and while covering the containerization, you also told we will do VMs and pros and cons of having between the containers and VMs.
Yes, VM, Docker will cover about Kubernetes, right? These things we can cover.
Yeah. Okay. Thank you.
Right. And in the next class, one more topic I will try to squeeze in is about Elasticsearch, right? Elasticsearch or search engines. Okay. So, because these are important from logging perspective, right? Something like this. Because if you know all this, then you will be able to handle any kind of system design question, right?
Sure.
And when we'll be covering all these topics, you will also get exposure to NoSQL databases here, because these designs will be based on NoSQL databases. Right. And we already discussed few of the NoSQL databases in the previous classes, for example, in payment gateway and in the tiny URL. Right? So there you can use also NoSQL databases also. So yes, this will, I would say, will be enabling you to answer any kind of questions in system design. You will have good expertise with this, right? Because that's more important. Following the schedule is not important. Important is that you should understand and you should learn each and every topic, and you should be able to clear the system design interviews, and you should be able to also discuss architecture, high level architecture with anyone. It could be in same organization or in any organization with full confidence, right? So do not worry about time frame. I will give additional classes in case required. But yes, definitely I feel that yes, currently on track, we have covered many topics. Awesome. Great. Sure. So I have uploaded I will be uploading the notes. I have uploaded until now, whatever we have covered, and for the remaining also, we will be up, you will get the notes uploaded. And yes, anytime if you have any questions, doubts and all, feel free to reach out to me. Sure. We will discuss, yes, choreography orchestration, we will discuss in the next class, because when we will be covering the message queues and Kafka, this will get covered. Right? Yeah, because there are so many topics, all these will be covered. Don't worry. Everything is subtopic of the remaining parts. So yeah, next class will be theoretical class, but yes, a lot of practical aspects also, because while I'm talking, we are all also covering the design of Amazon e-commerce system, right? So e-commerce system, we are also discussing online games, right? So a lot of variety of problems we are already discussing, right? So e-commerce means Amazon or Flipkart, right? These are all e-commerce application. Yes. Right, and when we will be covering message queue, I will also discuss one more use case, which is about Uber, right? Uber also uses something like message queue, Zomato, and Swiggy. These are also like Uber architecture. Only thing is Uber is more complicated. Zomato, Swiggy is less complicated because one destination is constant. You have to match the service providers and the customers, right? But in Uber, it is more complicated because destination is moving. In Zomato and Swiggy, hotel is same, right? Hotel is not moving. That's the only difference. Customer, yeah. Different.
Tarun, have we discussed Uber or are we going to discuss?
We are going to discuss, yes. In
Okay,
the next.
but like, is the time as like time? Can we able to make that time?
Yes, yes. Yes, with containerization, with message, we'll cover it in the next class. Otherwise, we'll take one additional class. Right?
Okay.
I'll take the 4th class, if not possible. If any topic, if we miss out any topic, always possible to have one more class. Right?
Sure.
It could be maybe one more doubt clearing class, right? Maybe just doubt clearing or revision class, something we can have, right? Correct. So anything, if I miss any topics, if you remaining topics, right? Sure. In case anything we could not cover in the next classes, but yes, as I said, I am okay to extend till 10:30. So be prepared to have a sessions like half an hour. All these classes 2:30, 2 hour 30-minute classes, right? Be ready. If we finish, then I'll leave you early. Otherwise, we will extend it, because more important is you should learn, right, all the topics. And yes, we will. This way we will be able to do, and if possible, we may also add another revision class or topic. This class, we'll check if possible. We'll make it possible, no problem.
Yeah. Okay, Tarun.
Right. So, but yes, we will ensure that each and every topic is covered, and you have good understanding of all the areas so that you can crack the interview. And definitely more now you have to work, and you should definitely more research may be needed from your side as well, because the perspective, the approach, you should also build from your side, your perspective as well. So yes, you have to also do these exercises as I'm doing in the class designing. Maybe you can preach, share each other your architecture, your way of architecting, because after understanding so many concepts, you may also think that yes, this could be another way of architecting this particular application. So you can keep discussing this. This is a good habit. This way you will always be becoming a better architect, and no architecture is 100% correct. All architecture has some weaknesses, It's always about taking trade-offs. So if you practice and do discussions on architecture with your peers, superiors, or with juniors as well, you will learn and you will also become good communicator, which is also very important for being an architect.
Thanks.
Great, awesome. See you then in the next class.